Hello students, today we're going to discuss how to solve data mining slash machine learning numerical problems. Like I just listed out the seven these data mining slash machine learning problems, especially modeling in terms of linear regression, logistic regression, polynomial regression. So regression aside, classification related decision trees. So in the decision trees, two versions we're going to see. So let's see how this is going to be solved in terms of using numerical way, as well as I just want to explain the coding perspective also. So with this knowledge, with this understanding, you're going to solve these numerical problems, modeling problems very easy. So hold on and listen carefully. So first problem, uh, before getting into the first problem, I just listed out the PDF in the description, as well as each this seven problems, each code you're going to find in collab files as well in the description, in the I mean beneath this video. So stay tuned and here is the first problem. First of all, I just want to go into the document of these seven problem statements. So this is the document. Yeah, this is the document. These are the seven problems you're going to find here. So first problem we are solving here, predicting house prices. So basically house price means a number. Usually we are using a question is also asking use a linear regression. So you're going to predict the price of a house here, right? So in this given data set we are finding how many? Three columns. Size is there, size of the house, zip code, like a pin code, and price, dollar, rupee, doesn't matter what is the your currency, but overall we are interested in how to predict the price of a particular size of the house, right? So we're going to feed this data to a model. What is that model? Linear regression. Linear regression, whenever you say, we are totally dealing with numbers, right? Numerical way. So before going into the code, first of all we have to solve, we have to fit this data into one line. Linear regression is all about that. One line meaning what is that? Y equal to mx plus b, right? So all these ideas you're going to follow up like that whenever you are seeing that this kind of data set, right? Especially that everything is clear. So is asking you need to predict a house price. I mean, with a size 1600 square feet with a zip code 1002. Okay. Then again to another problem also again 1400 square feet zip code width. Then what is the price of that house, right? So, but here is the problem is a little bit of tricky. It's a normal because he is saying what for houses zip codes one what is that 10,001 and 10,002 like this one and this one. The price is $10,000 higher, meaning it is usual price is going to be three. What is that? 3 lakh, 3 lakh. That's it. Here 1,002 also 3,60,000, right? Other houses are same. Maybe they are why they are having higher $10,000. Maybe they are the very expensive places. Maybe they are like a very luxurious places, very developed. We don't know what is the reason, but they are like a premium. That's why they are having $10,000 extra. So our data set is a little bit of problem. We need to refine it. How to refine it? Let's get back into our slide. So our first problem is all about predicting house price with zip premiums. And that is the one. And overall, our base thing, our target is what is that future we are based on the size, obviously, right? So I just refine this because this one 10,001 and 10,002 zip codes are having $10,000 extra, right? So I'm directly what I'm doing, I'm just subtracting them from them. So obviously we are getting 3 lakh 10,000 minus 10,000, we are getting 3 lakh dollars, as well as 1,002 zip code 3,70,000 minus 10,000. Again we are going to get like a 10,000 less, meaning 3,60,000. So again other 10,001 10,002 nothing there. There is 10,001 here also there, na? Yeah, 6,20,000. Again we are this subtracting from 10 from this number 10,000. Again we are getting 6,10,000. So other than this 10,003 10,003, only 10,001 and 10,002, those are the ones we have to subtract $10,000. Yeah, our data set is clear. Now it is refined. Why are we doing like this? where the data set is totally having like this after subtracting 1001, I mean 10,000, 10,002, because they are premium houses. That's why, because our data set, if we don't do that, if we don't adjust this price like this, our model is going to be like a faulty. It is not the way, the pattern is not going to be good. So we have to subtract the premium zip code $10,000. If we totally as a not going to delete this, again our model is going to be wrong, then our predictions are going to be bad. So it's all about that, right? Whatever the data we given, the model is also going to learn from the, I mean, totally train from that. Then based on the training, the predictions will be there. If your data is also faulty, if your data is not that much uniformity is not there, then the model is also going to be bad. That's why we are doing this kind of refining process here, right? Yeah. So next, we observe whenever the house size increases, automatically price increases. That is a simple observation based on this. And here, size of the house is not only the future. Here, we have to think about the how what is the thing. I just want to say here, based on this, like I just said, linear regression. We are talking. In the linear regression, we're talking meaning which is the one is affecting the price of the house. Obviously size. So we are predicting price, meaning we are price is adjusted price, or whatever the price is going to be y, and mx plus b, right? So x is obviously size. So we need to find out what y equal to mx plus b. We are finding linear regression, meaning we are totally feeding our data set, fitting in our data set into a line. In the line form, what is the line form? Y equal to mx plus b. In that we know y, that is going to be find out, predicting the given value. The given value meaning size x. So we need to find out what to get that line mx plus b. We know the x, mb. We need to find out mb, right? Yeah, m meaning slope, b meaning base price. Where is the initial price, right, of the house? Let's see how we going to find out. So I'm just saying that we have to totally fitting our data into a one line. That line meaning y equal to mx plus b, right? That is the one I'm talking. In that we know x obviously size. We need to find out what m and b. To find out m and b, we have found two formulas are there. What is that? M equal to slope of the line is equal to sum of product of deviations by sum of square of deviations for x. Okay, and in your exam or in your interviews or whatever these things, I mean, if you solve any kind of particular numerical problems, these things needs to be you need to be remembered. Okay, so calculate b equal to mean of 5 minus, I mean, m. Again, if you obviously you're going to find out m before finding b, right? That's why m into mean of x, right? Okay, x meaning here what? Size of the house, right? To find out this m and b, so we need to make one table so that we're going to find out what are the product of deviations, what are the sum of square of deviations for x. Let's see. So in the class also I explained this thing. So here we know that x is the size, that column fixed, we all know. Y pricing, I just look at that. This is a very much good observation, because we are in our data set, everything is just uh, here. You're all about 300, 3,10,000. I mean, obviously, suggested price 300,000, right? So I'm doing what? I'm just totally taking out. I mean, I'm just $1,000. I'm really want to use the number size very simple. That's why 300. Obviously, in $1,000, 450. In shortcut way, for our simplicity sake, I'm doing like this. Obviously, they are 300,000, but I'm just writing here like that. So after calculation also is going to be very easy. So after that, mean of x. What is the mean of x? This, where is the x? This one, right? This one, x size. So you're going to find out what are the number of what are some of the observations by number of observations. How many sum we going to sum of them by how many are there? One, 2, 3, 5, 5. Then it is if we doing this 1500 for each row, it is always 1500, right? Sum of x is 1500. That's why I wrote all this. Then mean of y, right? How many observation total? The sum of this y prices, meaning y meaning here what are that y price of that house, and we're going to sum of all these things by totally 1, 2, 3, 5 observations. Then you're going to get 450 of this mean of price of those houses, right? Then what is this x minus deviation, I mean we can x deviations, not minus. So we are thinking about how the deviations are there in the x sizes. That is going to be find out what is the formula x minus x bar, your mean of x. So where is x? This is the x. X by x bar meaning 1000 minus 1500 watt minus 500. 1500 minus 1500 watt 0. 1200 minus 1500 watt minus 300. 1800 minus 1500 watt 300. 2000 minus 1500 watts 500. Just like that y deviation also we're going to find. That is obviously y minus y bar. That is the formula we need to remember, right? So where is y? Here this 300. Where is mean of y? Here 300 minus 152. Again minus 58, 152. 450 minus 450. Obviously, what is that? 452 minus 450 minus 452 minus 2. 360 minus 452 minus 92. 540 minus 450 for 452. 66. Sorry, 88. 610 minus 452. 158. So this way again product of deviations here. Look, these two things we need to product them, multiply them. Then you're going to minus 500 into minus 152, you're going to minus into minus plus meaning 77 76 1000. Then 0 into something, obviously 0 to minus 2 0. Then minus 300 into minus 92 27,600. 300 into 6 88 26,400. 500 into 158 79,000. Then square of x deviations. Where are the x deviations? This is the x deviations now. For that we are totally squaring them. Minus 500 meaning minus to minus obviously plus. What is that? 25, I mean 2,50,000. Again, 0 square meaning 0 minus 390,000. 390,000, 500, 2,50,000. Yeah. So we are getting all these things, but in our formula, m equal to sum of product of deviations. What are the sum of product of deviations? This is the line we are following, right? This one, 70. We have to sum up these things. Then we are getting what? 2 lakh 9,000 and the sum of square of deviations for x. Sum of square of deviation. This one you need to sum them. Then you're going to get some 6,80,000, right? If you divide that, you're going to get what is the slope of the line? 0.3073. After that, what is the B value? Initial price of that base value, base price. That is mean of y. Mean of y how much? For 452. M is 0.3073 into mean of x. Mean of x 1500. Then you're going to get minus 8.95. So you're going to substitute these values y equal to mx plus b, right? Here I am writing y equal to b plus mx. Okay, no problem. So what is the b? Minus 8.95 plus m 0.3073 into size. So this is the adjusted price. This is the one we're going to get. So let's predict. These are the two problems we are saying, right? Yeah, this is the two questions they are asking. 1600 square feet, zip code 1002. What is the price? So observe, we just what is our whatever we got here, adjusted price. We just substitute. Size is equal to what? What is the size? 1600 square feet. Just to substitute that. Then you're going to get 482.73. That is the what is that? That is the dollars. But it is all about what? $1,000. Okay, 4,82,070. 4,82 482.70. I mean, $1,000 we're going to add here. That's why I'm saying here. I just to mention here. Sorry. So here it's zip 1,000 to add thousand $10,000 premium. This one you need to remember very carefully. That is the catch here. Okay. Final predict. We are totally here multiplication because here I'm taking $1,000, $1,000 because for simplicity of calculation. Then we are going to add multiply them. After that, because it's a obviously it's a premium zone house belongs to 10,000 to zip code. That's why we are adding $10,000 additionally. Then this is the predicted price. What is that? 4,92,730 dollars, right? But prediction two also like that. 49 square foot. Then you're going to substitute that 1,400 in terms of that is the size. That is the size of the house. Then but it is non-premium zone. You don't need to add any $10,000 here. You directly get $421.27, but you have to multiply with 10,000. I mean 1,000, because at that time we totally shorthand way we took. Then we're going to get 4,21,270 dollars. That's it. Our first problem done. This is the way. Let's have a look about the code now. Here I'm just I just imported pandas and numpy, and obviously I'm just feeding my data. Here, this is the data set given. This is the data set I'm totally feeding in terms of dictionary as well as list of values. Then I'm just converting this data dictionary into data frame, obviously using pandas. Then I'm just printing it out. It's totally mimicking same. Then what I'm doing here, I just adjusting the price here, because I said to 1001, I mean 10,000 and 10,000 zip codes are what? They need to be subtracted, because they are obviously inflated, right? Inflated or additionally they are premium houses. So I just adjusted that. Here I totally created new column. I didn't erase, I mean modify any that price column. I just added that, subtracted successfully, right? Using this LOC of this data frame, I mean pandas method. Okay, so have a look. We just is in if it is in this two zip code that adjust price. I'm just saying that the price should be 10,000 should be minus subtracted. So you can do it in this way using for loop also, but you can this is a simple way of doing that. After that, you are printing the data frame. Then I am doing what? This is the main thing. As per question, we have to use linear regression. So here we are doing what? Linear regression method scikit-learn. In that linear model I'm taking from linear regression class. I'm creating an instance of the linear regression class. After that, we need to give the features. What are the X is the future we are training on that size, right? Y is going to be the target output. So I am totally taking that X size of square foot of that. It is a one dimensional series we need to do in this way. Then again I am going to feed, it is going to be Y is in the form of list. Then uh, after that we are using the model fit method to that send those XY parameters. Then after that I just in this observe, here we totally find out MB na. So I am totally finding MB here in terms of using the coefficient and intercept. After feeding XY inside of it, we are getting that. Okay. So again we are the main problem here based on the given two problems. We are totally predicting here. Okay. We are predicting what are 1600, 1500 square feet. We are sending the sizes. Then we are getting 4,92,735 for the 600 square foot, 1400 square foot 4,21,265. So if you observe in our calculation also we are getting closely, I think 4,92,730. I mean $5. Okay, we are in mathematical way, and here for 1400, let's see, 4,21,265, 4,21,270. Again $5, little bit of gap there. But overall, our calculation and our model looks fine. So this is the way we going to step by step solve our these mathematical problems in terms of um, calculation as well as programmatical way. So let's go to second question. This question is going to be related to the misleading car action. Okay, let's open my second problem. So this misleading car auction, first of all, try to understand what is the problem here. Okay, so here we are not seeing any data set here. It is totally some kind of problem. Um First of all, read it. You are a data analyst, a car company, an action company. So it uses linear regression model, just like a line to predict final action price. So predicted price is going to get based on some your actioning meaning action meaning they whenever the maybe they are used cars or very luxury some like refurbished cars like a very trendy car so whatever that company is doing it but they're predicting prices in that and the problem with this model they're facing for they're saying for predicted price for 2,50,000 miles there it is giving minus for 300,000 miles it is giving minus value you observe meaning for anywhere a car if the predicted price is minus meaning the car is totally useless right why you give anyone give you like a other person who is owning the car he is going to give extra money to purchase this car other person no one is going to do that right otherwise he is going to give to scrap at least he will get some money in terms of that whatever the iron material or whatever of the car so our model is doing some kind of wrong here with this obviously that in the question that is these two things mentioned okay using linear regression model so based on this we understand our linear regression model somewhat wrong here okay because anywhere any cross price in the world especially in this data whatever the scenario we are facing compulsory that predicted price should be in the positive way not in the negative way right the average price at least it should be somewhere even if it is really going that much miles average it's mileage way whatever it running on on the roads but at least it should not be in the minuses okay right so what is this happening because we are saying in the problem is statement we are saying it is used linear regression line to fit all the data points. So, so what is the problem we are facing? Linear regression most of the time not fitting all the related, all the circumstances inside. Okay. So what is the problem? It is only looking at the linearity. It is not looking at the non-linearity way okay whenever the data be totally changes so that's why the main thing is whenever you are using linear regression you need to plot it out correctly you have to use it manual way even in a programmatical way also all the extreme ways you also doing this in this extreme that kind of very big mileage like that much of you observe here if it is goes like a 200 2,50,000 miles then it is giving that kind of a 300,000 like a 3 lakh miles then it's going to be like that way so linear regression is some kind of it is out of the box, out of the path here because of the non-linearity behavior in our data set. So what kind of thing we do? Whenever linear regression having this kind of problems, we have to look for other models to overcome this kind of non-linear nature in our data set. Okay. So in we can suggest like polynomial regression. There is a one way of doing these things. Otherwise, we can simply make it out using I mean make it up using our data points in terms of using log scale or scaling or different outliers or anything maybe that 2 lakh 200 like a very big words right big numbers maybe need to do that modify them so here that is the way so polynomial regression observe we all know that y equal to mx plus b but we are it is totally expanding those things in terms of miles is it classic and again we are multiplying miles and classic that means whatever the classic meaning that classic car is what kind of brand it is based on that also the value is going to be calculated so that non-linearity is going to be considered in terms of using other models not linear regression covered in the first place okay so we can't trust linear regression by blindly always we need to plot data to check patterns how the data is totally moving out of the linearity it is also or not a linear ladder line okay so polynomial meaning it is going to be somewhat like a line is not linear here right obviously So these kind of things, other kind of all these features also we need to consider. That is the solution we have to follow here. So simply this second problem is all about how a student understand the particular outlier business, as well as the model is not fitting the data correctly. That's why these kind of problems you may face, especially in your interviews. You're going to ask these kind of questions. Where is the model is doing mistake? Is it related to your data points, or the whatever the data scientist you took, one model totally following blindly, that one model fits everything, this kind of approach really good? These kind of questions they're going to ask you, they're going to test you, how you are looking at the data. They are really going to look into that way. So please students, I always observe how your data set is posing problems first. Then only you going to look into the data modeling. You get my point, right? Data modeling is always a tool that is going to improve, that is going to predict, that is going to classify the particular data set, right? So you are analyzing. First of all, if you want to analyze, if you want to find patterns, to go for that kind of models, first of all, you have to look with your eyes. So especially manually, you can plot it out. Maybe you can use this kind of different various models to understand which model is going to fit our model perfectly. That is the meaning of this. Otherwise, you that whatever the prediction you are using, that is going to be misleading the overall picture of the data set. From the overall picture of the data set, you understand what I'm saying? So let's get back to our coding perspective here. So here I just did a simple thing here. So observe here. Obviously, our linearity is going to be down whenever it is going to be mileages are improving. Obviously, even in the form here, I just it is not the correct way of interpreting, but try to observe what I'm saying. Here, the red color model is totally saying uh, it is totally becoming not good in terms of that. Maybe okay. So here I'm just taking some feeding the data into it. Again, after doing that, again I'm taking all these things. Okay. So this way, the second problem also going to be understood. Now we're getting back to our third problem. The third problem is going to be this: predicting drug effectiveness with polynomial regression. Okay. So here we are using polynomial regression now. So what is the drug dosage? How that is going to be improved? Percentage improvement. How much drug you are using? Then how the health is improving based on that. We're going to predict using polynomial regression the value. Okay. So here also I'm doing feeding all those things. After that, we are totally using polynomial, meaning it is separately not there. We are using linear regression, but using polynomial features, we're going to include into it. So after that, we're going to plot it out. This way, it is going to be printed out. Okay. So this way, we're going to understand. Now let's get back into problem 4. Sorry students, I think I didn't cover that problem 3 correctly because my slide is missing. So I'm directly getting into the problem 4. I think I'm very confident in the slide 4. I made it. Yeah, this one. Okay, this is the data set given fraud detection with imbalanced data and hidden rule. So data set is given. Based on this data set, we are understanding totally 8 records are there. 2 input features are there, amount and account age, and obviously one target is there. That is the classification, right? Is it 0 or 1? So say related to fraud detection. If fraud is totally fraudulent, meaning it is going to be 1. It is not fraudulent, meaning it is going to be 0. Okay. So our prediction based on the question, we need to look into $18,000 from an account aged 4 days is fraudulent. Okay, we need to predict is it fraudulent or not using what? Logistic regression. So just observe 18,000 meaning where it totally fitting into again it is obvious account age how many account is operating 4 days is up saying. Okay, so based on that because this is simple understanding about the given data set in your exam also you write like this kind of first of all explain about the data set. It is really clear so then at least you will get some marks. So what are the features are there? What is the based on that? What is the dependent? What is the independent variable? This kind of target is there. These kind of things you need to explain like this. So what is the hidden rule? Is saying the amount greater than 10,000 and account is less than 7 days. Okay, I mean amount then it is going to be always fraud. Okay, that is the hidden rule. Is saying. But these kind of hidden rules, whenever someone mentioning, okay, it is totally out of the context. Our model never going to learn this kind of particular specific rules. You get my point, what I'm saying. So our data set is like this. Maybe I just want to get into this, just observe. I just what I'm doing here, I'm just scaling the data points in terms of dividing into 10,000 and again age is going to be 10 so that it is going to be easy because these are a little bit of big numbers, right? So I'm just converting them to small numbers so that it is easy to operate. Again, just observe hidden rule is what whenever you're going to have what 10,000 here, 10,000 will print to 1.2 meaning 12. What is that again? 12,000, right? So that's why uh, again less than 7 days always obviously going to be it is going to be always fraud meaning 1. Again, you observe greater than 10,000 is saying suddenly greater it is less than it is 8 meaning what 8,000 0.8 meaning 8,000 but it is less than 7 days that's fine that is 1 day but obviously it is fraud so that is not following the hidden rule that's why I wrote not by rule so two instances following the hidden rule one instance not following so this kind of things if you feed into the some kind of model so based on this kind of hidden rule they mean it, the model not going to understand okay that's what I'm saying. So before getting into all these things, first of all, we are using what logistic regression, obviously. Is it correct? Logistic regression. What is the formula? 1 plus, I mean 1 by 1 plus e power minus, I mean by that mx plus b. We can improve it if you have multiple features, then we're going to do that amount age based on that. Here the problem here I just in the class also mentioned P naught, B1, B2, whatever that. These things are totally some based on that some other formula. We go in exam. If you may not get these values, then you simply what you going to do? Whatever the default values you have to remember. At least you have to give close related values to calculate. If in exam the particular values is not given, I'm just saying because these values are find from other kind of process because I'm not going to explain those things so these coefficients are there these okay so we just substitute them then we're going to get nearly what is that 94.26 percentage so based on that whenever you're getting more than 50% then obviously the prediction is going to be true in that case it is fraud so this way we understand the given what is the problem they are asking. Whenever you are getting $18,000 aged 4, it is going to be fraud. That is the one. This is the problem. We solved problem 4 done. It is very easy. I said very clearly. You don't need whenever if it is not given the coefficients, you simply write your values, whatever the value. You need to remember these values, obviously. Otherwise, at least you can tell them this process is not going to work. You explain them in some words, then at least they will the regulator may give marks. That's what I'm saying. Okay. So let's get back into our code. Yeah. This one is a hidden thing, right? So logistic regression I'm importing from scikit-learn linear model. Then I just feeding the data into data frame. Then obviously I just scaling them. Okay, obviously I just told you. Then again I improve. I'm totally taking the logistic regression. The hidden rule I'm totally feeding in also here. Then I'm totally getting the fraud here. So this obviously students are totally attaching. I mean uploading. You get this collab file in the description. Do not miss those. You just practice. Okay. So let's get back into problem 5 now. So what is the problem 5? Predicting customer churn with interaction effects and non-linearity. What is the customer churn? So customer churn meaning the customer may leave, is leaving from the service. That is the one we're going to predict. Especially a lot of people are using networks, internet service or a dish service or whatever. So the companies needs to understand the next month this potential customer may leave the my platform or not. If they leave, how they we need to stop them. Based on that, they're going to give some advertisements or some policies, some recharge, all these things. So the customer churn meaning whoever not satisfied with this, the businesses needs to know why the people are not satisfying with their service. That's why they need to analyze, they need to predict, right? Their customer churn with, but this is all about it is non-linear. Whenever it is obvious a particular user, his behavior, his habits, and all these things, we never going to say in a particular linear way. Compulsory the non-linearity is there. Okay, so all these things we need to understand to predict that customer churn. Okay, let's have a look. This is the data set given. Okay, some customer IDs, some say 8 customers are there. How much time they are totally is related to I mean SIM service, I mean cell service. How much time we talked on the phone, okay, for some time, 200 minutes, 150 minutes like that. Data usage, how much GB is used, 3 GB. So contract renewal, okay, is going to be renewal meaning is going to be recharge or not, otherwise is going to other places. That is the one. Here one meaning, here contract renewal is going to be one, S is going to renewal, zero. The churn is not going to renewal, meaning is going to be churn here. Okay, is leaving maybe. You understand, observe. You are totally looking like this, and here observe 8 customers are there. Total call duration minutes there. Data is a GB is there. Contract renewal wise or no. So this kind of way, target churn 1 equal to yes, 0 equal to no. So this way we're going to see. Now it is problem 6. It is a loan default prediction using ID3 decision tree. So let's have a look of the problem. So in decision tree, we are having some versions like ID3, and another version is also there. That is also explained in seventh problem, C 4.5 decision tree. But basically, they are related to some entropy, some ratio related thing. We will discussing more. But before getting into it, first of all, we are looking into this ID3. So decision tree is basically is we are looking at two versions. First version is ID3 we are looking. So what do you mean by ID3 algorithm of decision tree? So we have some problem here and we are given a data set. Here obviously some customer IDs there, 8 records there, 8 members. And what is their income level? Is it high, medium, low? And credit score? Is it good, fair, poor? In that 3 classes we are seeing status. If he is that particular customer is employed, unemployed, like that. 2 classes we are seeing here. And target. So the default is what is the tower default is going to be no or yes. Two things we are looking, right? So in this way we going to split them. I think which feature is going to be played key role in this all these things because decision tree is all about like yes or no like sequence, right? If it is yes, then we go there. Otherwise, no, we're going to stop there. So this kind of thing is like those kind of structure we're going to form based on this given data set. So that what is the question is asking. So what shard root should be the root node, right? So in this lot of features are there. Obviously, the we will target. Other than that, we will be remaining this income level, credit score, employment status, which is indeed which is going to be the root node. That is asking. So what is the predicted class for a customer with income medium, credit fair, easy, and that particular person is employed? Then is it going to be which class? Is it going to be yes or no? I mean, we are totally looking at is a loan default, right? I mean, they're going to be pay or not. That is going to be looking into this using this addition tree in terms of ID3 algorithm, right? So let's solve this step by step. So this is the data set as we just observed. And let's get back into this, the overall summary of the data set. In terms of the adjusted income is total three types, credit score is three types, employment only two, employed or unemployed. The target is the SR is going to be pay the money or not because he's having a loan. In terms of those three things, we're going to decide. Our goal is build a decision tree using ID3 algorithm, identify the best root node, and predict for that kind of person. Is it that his income is medium, credit is fair, and is obviously employed. Then we're going to predict is it going to be pay the money, yes or no, is going to be totally loan is going to be defaulted, right? So then our goal is build a decision tree that can predict it's going to be yes or no for new people. That is the prediction we're going to look. So how are we going to do that? We are using, obviously, we want to understand the learning patterns inside of the given data set using ID3 of the decision tree. So what is ID3? It's a decision tree. Obviously, it is going to ask the smart questions like which question to ask first. Is the person employed? We are observing. If he is employed, then obviously he may pay the money back after taking the loan, right? If his income level is very much high, then obviously if he's low and if he's unemployed, if his credit score poor, then we may guess he's not going to pay. He's going to be defaulted. So these kind of things we look. What are the smart question about a particular person? So those kind of things are going to tell the particular bank we're going to give the loan or not, right? Based on the decision tree, we're going to see. So these things is going to be only happen once we have to take one consideration, one feature, then getting into it again and again, right? So you split the data based on the answers, right? So what do you mean by ID3? So ID3 meaning iterative, uh, dichotomizer, dichotomizer, dichotomizer tree. So it will, I mean, this here we don't care about the full form here. We just understand how it is going to work out for our problem. So it is going to be build obvious decision tree, asking the best smart questions that gives the most information gain. So we are looking here two things. We need to get the information. There is we call gain, and we need to reduce the entropy. What do you mean by entropy? What do you mean by information gain? Let's see. So IDC picks the best question, how pure the answers become. Meaning, whenever the pure, meaning all the data points should be in the same way. The results need to be same way. Okay. Then the entropy is going to be zero. Then information is going to be high. That is thing we need to information. We look into it. Let's solve. What do you mean by entropy? For example, things contains all the mixed values. Then your entropy is high. For example, the 50-50 mix, like just observe here in our data set, how many SR nodes are there? Like 1, 2, 3, 4, 4 nodes, S, 1, 2, 3, 4. Those are the default targets, 4. So 50-50 is there. That meaning what? That is entropy is 1. It's totally impure. If it is all the values S, then it is going to be 0. Entropy is 0. If all the values no, then entropy is going to be 0. I said entropy should be very much minimum. Then we call it is pure. The data points are pure. But here 50-50 meaning it is not going to be good. Then we're going to say entropy is maximum. That is totally we can say impurity. So we need to reduce it, right? Overall, for the given whatever the defaulted for is. So we have the formula there. So using this formula minus p log of p plus p, I mean whatever the pluses here, meaning s's are there, 4 by totally 8 of 4 s, again 4 minus 4 by 8. I just substitute those in formula, log zero point 0.5 we get for 1.0, but it is, I'm just saying, I just said entropy 1.0, but I'm giving the justification here using the formula of entropy. So overall, the entropy of the data set 1.0. As I said, entropy should be minimum. Then only information gain is going to be happen. That is going to be, that particular feature is going to play the key role in terms of making decision tree. But here is not happening because we are having entropy maximum. Let's see now what we do. Information gain formula, we are looking into this, the information gain formula. We're going to entropy should be based on that we're going to subtract. Let's see. Get back into it. Try splitting. Now for whole data set is not all the data points are very impure. Now what we do, based on the two groups, we are taking employed. Here employed, unemployed. Let's say here let's have like look like this. Here employed are there. This is the one employment status we are looking here. How many members are employed? One, two, three. Four members are employed. How many? One, two, three, four. Four members are unemployed. So here, I mean, just employed. How many customers? One, two, three, seven. Here, one, two, three, seven are employed. So, and the customers are unemployed. Four, five, six, eight. Other than that, one, two, three, seven. So each subgroup is pure. Here employed customer 1237 totally a, meaning entropy here is gain of employment based on this entropy obviously 1.0 we get here. Just observe what I'm saying. Employed employment, we take employed and unemployed, two classes we are taking here. In that first case we are only looking at they are totally mixed, but here employed is one class, unemployed is one class. They are totally in that they are totally having how, just observe, they're totally having that they are no here indicating employed are totally no, 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 again no, and unemployed yes, 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 yes. That's what we're saying. All employed are totally no's are there. Unemployed all are yes are there. If they are anything, for example, customer three employed person example here. If he is an S there, then again the employment is not going to be good. It is going to be impure. Now, whatever the employed, we are looking at SR no's only because we are looking at what target is. Here is what target is here. What loan is going to be paid or not. That's what we are looking, right? So based on that, we are total looking for bet into 0 and all these things 1.0. And now we are getting gain is 1.0. Based on that, we say employment is the root node here directly. If you are looking like a income also same income, same you can do it income. Where is the income? This one. How that high and high, where is the high? That's it. High twos, no's are there. Very good. Mediums, no yes. This is totally impure. Are you observing? Again, low, yes, yes, no. Again, lows are impure. And medium, no, yes, yes. Again, impure. So you are observing what you are doing. Your income is not the root node because it's lot of impurities are there. You observe what I'm saying, but the same you can do it like that. So spice splitting credit, that is also you can do it. So where is the credit? Again look good, good no, good no. Where is the good? That's it. Good is pure, fair, fair no, fair yes. Again it is totally impure. You get my point. So based on these three, which one is good? Employment status is good. So directly we write choose the root node is bet split equal to employment. Okay, then we have to draw the tree. If employment equal to employed, obviously we see employed is all about no, no, no. Unemployed is all about S, 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 right? Then we simply draw the tree. So what is our question? Just get back into it. For income medium, okay, for income medium, fair, employed. If he is employed, obviously, if he is employed, obviously he is employed, right? So obviously we can predict no, he is not going to pay, is going not going to pay the loan. That is the because of this employed is no. So this way we going to draw the decision tree using ID3. You are observing what I am saying here. Okay, iterative dichotomizer 3 of a version of the addition tree, we're totally looking at entropy. Entropy should be less, meaning yeah, all the things should be pure and information gain is happening. Then we're going to draw, we're going to look into which column is going to be play the key role in terms of getting that alone default. Is it going to be yes or no? Then we're going to look into that based on that particular column in terms of entropy less, and, entropy should be less, and the information should be high, right? This is let's have a look of the code here. So here I'm doing directly decision tree classifier I'm taking. I mean, separately we don't have ID3 that kind of thing here. We're simply using here. Look at this. I just want to say we simply mentioned entropy that tells you we are using ID3. Okay, because there is a separate nothing in a scale and this scikit-learn we're not getting. So obviously we are getting no. So I totally in the description you find this collab notebook. Okay. So in exam, based on the given question, you have to solve the problem. You have to justify. You may not ask me, so I need to write code. I did I write? I mean, do I have to read the code? It's all about the requirement. If they are going to solve a particular numerical way, you're going to solve based on this way. Okay, based on the slides. Prepare live based on this way. Okay. So next we go for um, another problem and problem number 7. So So problem number 7, this is the one, the last problem in the given document. Okay. So predicting customer subscription using C4.5 decision tree, another version of it. This is the given data set. Okay, let's look at that. Okay, based on that. So let's have a look of the given data set. Totally 8 customers are there. We're going to look at the customer subscription. So first of all, age group is there is young, adult, senior, like that. Usage hours low, medium, high. Device type mobile, desktop, tablet. Previous subscriber is it yes, no, two classes. Target subscribe target. That is the one we have to follow. Yes, no, yes. So we going to build one decision tree so that we say the particular subscribe is going to be yes or no. Okay, let's this in exam also you have to write like that before you don't understand anything. At least write something about the given data set. Then at least you get some marks. Okay, what do you want to predict? Is it going to be subscriber or not? I just explained age group was there, usage was there, device type, previous subscriber, yes or no. In that way, we're going to look. Then what do you mean by C.4.5 algorithm here? It is the we're going to find out best root node. I mean best attribute just like before ID. Um, Before here, just I'm just scrolling. Based on this tree, here also we are splitting the ID3 decision tree. Here also we are looking, but in another version. Let's have a look how it is going to be. Okay. So what do you mean by C4.5? What is the difference between ID3? It is the improved version of ID3. That's it. It chooses the best feature to split using. Now before this we are using employment, right? Based on that we split compared to other features. So but here we are looking more not only entropy information gain, we are looking gain ratio. Okay, not only information gain, we are looking gain ratio, another formula, new formula coming. Okay, it corrects a problem in ID3 because attributes with many values always look better. But 4.5 divides the gain by something called split info because we can call gain based on the gain ratio. Let's have a look. These are the four because entropy, you know the formula, information gain, you obviously know, and split info and gain ratio. These three things again additionally come into this C4.5. Okay. Additionally, we have more than ID3, right? Right. So let's, what are the count class values? Let's have a look. First SR knows. Based on that, let's get back into our data set. Let's have a look. This is the data set, right? Last 4.5, yeah. So target how many nodes? 1, 2, 3, 4. How many yeses? 1, 2, 3, 4. Yeah, totally 4. Again, we are 4 by 4. Again, we are getting 1.0 entropy because they are half of it. They are not, there should be SS or there should be no. Otherwise, if you have this mix up, it's always impure, right? Right, attributes one by one. Let's one by one. Let's see age group. We are taking age group here. Okay, based on that we're going to make, obviously our aim is to make one dictionary, right? So based on that young adult senior, in that attributes we are having what? Three young adult senior, right? So in young, where is the young? All no 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 yes. Again we are have no no yes. Two no's, one yes. Not good. Adult, adult. Where is the here? Yes. And no here no. Yes. Adult no. Again yes no. Yes yes no yes. Correct. Senior. Senior where? Senior no. Senior no. Senior yes. No S. One no one yes. Based on that we calculate gain and gain ratio. Entropy for young. So here 2 by 3 out of it log 2 by 3 minus 1 by 3 log 2. When we get this kind of nearly this 91.8%, but not good. Okay. Entropy for senior also same. You're going to find out for young adult each class I am taking. Here look at that. 2 no's 2 by 3 out of total 3. Again 1 out of total 3. Then we are for young we are getting entropy. For adult we are getting same just like this same 2 by 3 same value. But here entropy for senior is going to be 2 now. So 1 by 2 log of 1 by 2 minus 1 by 2 log 1 by 2 base 2. That is going to be calculated. Okay, so now awaited average entropy. So then again, this formula needs to be there because we are having the one feature, we have multiple classes there. That's why we have to wait at taking combination of all the entropies. That is the formula. This. So what we are doing here, whatever we are getting, because this 0.918, how much it is getting? Totally we are having three. Yes or no? These three classes are there, na? Out of how many? Totally, we in a data set 8 records are there. That's why 3 by 8 into 0.918. Again, getting here also how many classes? 3 adults. Meaning 3 by 8. Again, it's going to what? 0.918 now for this what are adults also. Senior, how many? Total 2 by 8. 2 classes, 2 by 8 into how much? 1.0. Let's do 2 by 8, 1.0. Are you observing what I'm doing? So you calculate, you get some value, use your scientific calculator so that in exam it will be fine. So just like that, what is the gain of totally 1.0? You are getting by this much of 6.115% you are getting gain. So split in 4 based on the formula you are observing, you're going to get this kind of again gain ratio formula you're getting 3.94%. So based on that, again, till now only I observe age group only. Again, we have another three usage hours, device type, subscriber. Which one is good? It's like a race. Which is really good in terms of not only entropy, information gain, split info, gain ratio. Based on that, we are observing. So one by one, we have to do it in exam also. For the exam sake, try to at least one or two you do for the sake of the marks. Because sometimes some maybe wherever some mistakes you may make because it's all about doing practice. But I am also doing in this demo. I just stopped here because I'm just is doing age and I am just to try after usage you can try device low GR meaning based on that you can observe in device mobile mobile again where is mobile here no yes again impurities we are finding desktop yes no again you are finding impurities based on that also you can calculate you observe it is like a guessing work because data set is very small you can observe how the impurities based on that impurities also you can guess which feature is really approximately good in the gain ratio here we are looking the previous is really good compared to previous where is the previous subscriber so here no okay like all the things good yes okay all the things good that gives you gain ratio 1.0 based on that observation also you can do but my suggestion is whenever you get kind of observation, you simply do not do this taking like a this direct age group directly. Which one is really good? Impure. I mean, avoiding impure, going for purity. Just to do it this all way you can save from a lot of this kind of hustle okay because you need to have very good root node that have more in gain ratio right so here previous subscriber is giving good the I mean it is going to be giving the top root node for our decision tree so previous subscriber that is the highest gain ratio so we worst attribute best attribute is going to previous subscriber because we have the gain ratio 1.0 So right. So here let's have a look. We need to predict. You can draw the decision tree, but I just want to see prediction here. What is the question is asking? Okay, that one question is completed. What is that previous subscriber is will be the root node? And the second question for age adult use medium usage medium for this just a previous subscriber no. For this is going to be yes or no. Okay, here a total right use tree previous subscriber root value equal to is saying what? Value equal previous value equal no and it's no check all the rows where previous no who is subscribed. Row one, for example, no where we are looking here observe. I just want to go for the data set again. Okay, row one here we are looking where which always the previous equal to no. Okay, no meaning who subscribed no. Row two no. Row four again no. Row five again no. Row 8, no S. Yes. So now for number one is majority is no. Final prediction also no. One thing is going to be yes, but compared to other rows, no's are dominating. That's why our prediction is going to be no. So this way we going to make our decision trees here C4.5. So let's have a look of our code. Sorry, just yeah. Here, so 4.5. Here also we are looking intro based on that we are approximating C 4.5. Okay, we are getting no here. So student, this notebook also you may find in the description. So students, what my simple thing is, you whenever you get the question in exam or interview, first of all you just observe the data set clearly. First, give your thoughts about it. Then, based on that discussion, never directly get into the code. First, understand because a lot of problems because pre-processing need to be done very clearly. Then only you going to get into the modeling. Okay, understand the patterns, right? Even if the put data set, it is all about easy to understand with our eyes. We can understand, we can totally interpret what is going on there. Okay, so this way we going to um, wrap up the session. We're going to write the exams and attempt the interviews very well in machine learning and data mining uh, regard. And thank you, students. And you just find all the things in the description. Thank you. Bye.